Ashley, did you get my email?
Yes, and Dr. Klon saw it.
Thank you. We're just waiting on Dr. Klein, so we'll be starting shortly.
Afternoon, everyone, and I'm going to give this another minute to allow other folks to join us, and then we'll kick this off. I generally wait till 1 or 2 minutes after the hour because people are always just a little bit late because they're very busy. Okay, why don't we go ahead and get started? Good afternoon, everyone. Welcome to the Research Town Hall for the month of June. We'll be missing a lot of our colleagues who are on 9-month contracts, and so I expect a smaller turnout, but I feel badly for them because this is a terrific lineup today of speakers. I wanted to start out with a couple announcements and some informational items. The first one is update on F&A at the federal level. Some of you follow this very closely, others maybe not so much. Um, the the national university representative organizations such as the AAMC and the American Council on Education have formed a joint advisory group to engage with Congress on F&A models. It's a really impressive group of people. They have recently discussed in public 2 models that they have proposed to Congress. And without going into the details, because we don't know what the final model will look like, I think that there are challenges in each model, and then there are aspects of them that we can certainly live with. They've been well received by Congress, which is surprising, but also encouraging. And we should probably not know more until, I would guess, late October, November, December at the earliest. The wheels of the appropriations process grind slowly, and maybe not exceedingly fine, but they do grind slowly. Second thing is a funding update. And I have to say that compared to the first 2 months of the spring semester, the final 2 months have been a little quieter. We've had when all is said and done, to date, the university has had about $1,300,000 in grants canceled in this calendar year, or in this fiscal year, rather. The funding that would have come through the expected renewal of those grants adds up somewhere closer to $4 million, $5 million of funding lost in the remaining period of time that the grants had. Compared to some of our partner and peer institution, that's not as bad. It's still the loss of each grant is a tragedy, because the folks who write grants and who live by them know how hard it is, and this is discouraging. I guess it's sort of the cup is either half full or half empty, depending on how you choose to look at this. We've also had some funding restored. Yesterday, we heard that the federal funding for the Manufacturing Extension Partnership, which had been ended, was restored, and some of the partnership members had received 5 years of funding. So we're going to take that as a win as well. And then finally, there's an impression around the country among research officers, research vice presidents, that the NIH certainly is beginning to pick up its pace from the freeze that it was in terms of advisory councils, and study sections are getting back to a more regular pattern of meeting. That's good news, because we certainly can't see any money flow until advisory councils meet. Last thing I want to mention is some personnel changes. We have been without, in the research office, we've been out without a marketing and communications person since early January. Our new marketing communications person is Ashley Striegel, who comes to us from the Delphi Center. And today is her first day, so you can use your applause emoji, and there's Ashley right there. Hi, Ashley.
Hi,
Welcome.
nice to meet you all.
It's great that you're over here. And the second thing is that, we advertised the position for Vice President for Research, Operations, and Strategy for our office. Really reinventing the office has been one of the tasks of the last 6 months. We had 3 outstanding candidates, and I wanted to announce today that the person who will begin to fill this new role is Kevin Merton, who will be returning from the University of Alabama, Birmingham. Kevin brings over 13 years experience in the Office of Research and Innovation, and he's delighted to be returning home to this new role, which is quite different from his previous role. He will be focusing on strategy to a great extent, as well as operations within the office, and then we'll also have sponsored programs reporting up to him. So it's a much more focused job, and we're just delighted that we were able to get him back. So with that, I'm going to turn this over to Dr. Stephen Jones, who's the director of the Center for Cardiometabolic Science. That's really what the program is about today. I'm super excited. This is a high achieving group that is, really hitting on all cylinders. And so I'm delighted. Steve, would you take it, please?
Yes, sir. Thanks, Dr. Klein. Cecilia, if I go ahead and steer, should work just fine, right? Screen.
Yeah, you should have no problems.
So everything.
We can see you. You just need to be in presenter view.
Looks
Perfect.
great. Looking good? All right.
Looks good.
Great. So thanks everybody for joining today, and thanks John for the introduction. As a fellow Louisianan, I would just say, although we would have both liked the Cards to have gone a little bit farther in the College World Series, go Tigers. for the win on the national championship. But that said, let's get into what we're going to talk about. So a few of you on this call are familiar with who we are and what we do. So don't worry, there'll be a few tidbits in here about kind of where we're going in the future. And unless you're kind of within the center, you might not know exactly what that direction is. If you don't know us, don't worry. We'll talk to you a bit about what we have been doing and some of the things that we're a bit better known for. In terms of orientation, so as Dr. Klein mentioned, I direct the Center for Cardiometabolic Science. The two other gentlemen joining today, Drs. Hellman and Gibb, are also in the center. They are bedrocks of the center along with a number of other folks. But one of the things that people get confused by is the sort of admixture of us with the other folks in the envirome. So to be clear, our center is the largest and oldest center in the Envirome Institute, which is led by Dr. Aruni Bhatnagar. Aruni started this center in the form of the Diabetes and Obesity Center about 17 years ago, but who's counting? And then we changed the name a few years ago after I took over to the Center for Cardiometabolic Science, which, nothing completely captures everything we do, but it moves a bit more in the direction of capturing what the plurality of folks do. So one of the most important things about us, perhaps the most important is what I would argue, is the people that we're composed of. We're only who we are and what we can be because of the great group that we have. It's a truly cordial, collegial, collaborative, interactive group, whether this is on the faculty, the trainee level, the staff level, the administrative level, all across the board. It's a wonderful group to work with. This is not just a marketing or recruiting slogan. It's actually the truth. So a little bit about our census, like what is our composition? We have quite a few PhD students. Most of them are biochemistry and physiology. Usually we have anywhere from 1 to 3 pharm tox PhD students as well, anywhere from 1 to 3 of those total graduate students being MD PhD students. We have a few undergraduate students, which is typical for my colleagues joining from Belknap. It's pretty typical for us actually not to have too many undergraduates just because most of them come from the Belknap campus. And then we're in total 15 faculty members. 2 of those are fully service track, and I'll mention them in just a moment. We're like a lot of the other folks on HSC. There's a lot of, eat what you kill what you eat type of support that complements that comes from the dean and the EVPRI and the university writ large. One of the things that we are, particularly proud of is the high rate of funding for the fellowships for our trainees in the center. We, right now, I think we're maybe only 1 or 2 of the folks that are actually eligible have not yet activated their fellowships. On that note, one of the things we take pride on is not just the success in terms of bringing in fellowships, but our intentional development. So this is one of our placeholders for what we call the Academy. Yes, we have no shame. We will use that Academy that we will model ourselves off of. This is led by Dr. Brad Hill, who's the Associate Director of the Center. Don't call him the Deputy Director. He is the Associate Director. And this is a long line of thinkers from antiquity to a bit more modern folks in the more specific cardiovascular lineage that ultimately will lead to us. But how do we get there? We get there through a number of regular interactions, whether it's center conference, intentional development that's for both the faculty and the trainees. The faculty, whether it's mentorship training, the CIMER or CEMER, as it's called, that we've been doing for a couple of years now. We have interest groups, and we're not going to spend too much time on this. Some of the things that are a bit of our DNA is how we interact. I mentioned at the top that's a very collaborative and interactive group. It's been a while now since we've had many of our fellowship applications go out where we don't have 2 formal mentors, that is a mentor and a co-mentor on there, and then they lead a larger mentorship team, which has been identified. This is the way. I mean, there's not another way to do it. This is the best way to do it. This is modern contemporary best practice to have mentorship teams. We have a trainee day, and we've talked about the fellowships as well. One of the things that we also think is quite important, and again, there are not trainees on this call. This is really kind of perhaps giving unsolicited advice to some of the other faculty that are on this call. Is really the notion of not just being a PI, being a boss, but being a sponsor, being an advocate, being a supporter lifelong for the trainees that come through your program. It takes energy, but it's certainly worth it. So that's a bit about kind of the underlying ethos that may be a bit hard to identify from the outside. what are the questions that move us? Why are we here? Why do we get up in the morning? So I want to start from the top, connecting back to our other human studies colleagues in the Envirome, such as the Green Heart A-Track with Sundar Srivastava, and then some of our local colleagues here in the center, such as Drs. Conklin, Carl, and Aberzettel, basically who have been studying various aspects of either, you can argue choice, or addiction is not so much a choice, but the use of tobacco or tobacco substitution products such as vaping, and how that could impact cardiovascular health, how the larger environment, such as work again by Dr. Conklin, Dr. Aberzettel, and also Dr. Sansbury, can also impact cardiovascular health as well. And so we're kind of setting this up as you see these pictographics being sort of these foils, sort of good on the left and perhaps deleterious on the right. So obviously nutrition is a growing area. So there's been quite a history, say with Craig McLean's group, there's a lot of momentum in that regard. Matt Cave and Brad Hill just submitted a COBRA that will address in part this issue. And that's something that we're quite excited about going forward in. Sedentarism versus physical activity or exercise. This is something that's long been an interest. You're going to hear more about that today from the subsequent speakers. One of the newer areas, which we'll touch on in a minute, sleep or lack thereof. Obviously, drugs. There are some pharmaceuticals that can bolster cardiovascular health, and then some that can impact it. And obviously, ultimately, we want to aspire to understanding the various factors that you can and can't control and how they can uphold and support cardiovascular health, and the factors that it can antagonize it and promote cardiac dysfunction. How do we do all of this? So we have a few approaches that we use. Some of those are known to you. It's part of our name, such as metabolism. Also inflammation. You're going to hear, again, a bit more about both of these two today from Dr. Gibb and Dr. Hellman. We do this obviously with an ultimate shot toward cardiovascular function, which is something that we're well known for. We are nimble with imaging, which we'll touch on a little bit about the opportunities that we have here. And of course, it's 2025. No one can operate without close support of a bioinformatician, which we have in the form of Dr. Richa Singhal, who is our local node of the bioinformatics larger ecosystem here that is led by Dr. Eric Rushka in biochemistry. So how do we do all of these things? Well, we can do all of these things because we have a lot of expertise in various areas, and whether that expertise was bought, brought, or earned, we can do a lot of these things now. Now, what you will hear, a couple of the items I'll mention are cardiovascular specific, but what you will also hopefully come away from is realizing that most of these core services are actually not cardiovascular specific. In point of fact, they are quite broad and applicable to a number of folks. So one of the domains of the core services we have are in the physiology course. It's led by Dr. Yibing Nong. We have ultrasound imaging. Again, we call it echocardiography. That's just when it's specifically applied to the cardiovascular system, but the ultrasound can be applied to anything. I think I saw Dr. Walong join the call in Dr. Cave's group. We had worked with them before. Dr. Lisa Sandell in the dental school, we'd worked with her before as well. Some of the in utero work, so imaging mice in utero, looking at oral cavity development. Yeah, that's something that we can do. So this ultrasound was purchased by an S10 5-6 years ago, and then Dr. Nong recently was awarded, and 30 minutes ago, it was just delivered a new ultrasound system to expand and support our systems there. So if you see him, give him a good pat on the back and tell him attaboy for getting that. Obviously, we can do everything cardiovascular. Our center is the single greatest concentration of cardiovascular investigators on campus. We can do surgeries related to cardiovascular system, but we can do other things too as needed. We've been able to develop new modalities as needed. We have a full pathology suite. This is led by Dr. Ning Chen and Ken Britton, really on the pathology side. Processor embedded microtomes. We have a Nikon A1 confocal microscope, an epifluorescent system that is a bit of a medium throughput system, a Bruker atomic force microscope. This is one, maybe almost 2 years old, a very new state-of-the-art system. And then in partnership with the VA, we have a Nikon multiphoton confocal microscope. This is a real beast. Its twin sister is in the CTR, so I think in the GI hepatology footprint. You're going to hear a little bit more in the next speaker about the metabolic profiling core that's run by Dr. Hellman. And that will, I'm not going to talk too much about this because you'll hear about that. I think you may hear a bit touched on, or at least mentioned from Dr. Gibb, about some of our advanced metabolomics that we're doing here in terms of the data analysis side. Mitochondrial oxygen consumption, a lot of you know from Brad Hill, who's an expert in that area. And then Dr. Hellman might also mention the Sable-Promethean system when he's presenting shortly. I think you guys have heard quite a bit about the VASES or the exposure system led by Dan Conklin. So that's why I've not really talked about the toxicology folks here in the center. I did mention them at the top, but Dr. Conklin, if you're interested in exposing animals to the air that we breathe when we walk down the street, that's a very unique facility that he established and led for the last, better part of a decade now. And then we have a number of other miscellaneous things that we're not going to bother. Either they're too pedestrian or they're just too small to mention here, but we have quite a few things. If there's some of these modalities that you're interested in implementing in your laboratory, please give us a call. We have training for some things. We can't necessarily teach you everything about heart failure in a meeting or two, but we can certainly, if you know how to perform confocal microscopy, we can certainly train you on the system. We have an electronic booking and billing system as well. We're known for doing heart failure. This is just a kind of a way to kind of put faces in front of you. A number of the folks you're going to see Dr. Gibb here soon. Dr. Hill is on the call. Dr. Sophie Sears, one of the new recruits, along with Dr. Gibb, Dr. Baba, Dr. Moore, Dr. Collins. All of these folks are studying various aspects, whether it's inflammation, metabolism, or fibrosis, and of course, in some, as you'll hear about later, looking at other organs and their interaction with the heart. These are the areas that are a little bit newer. So we have now a grand total, we have an infinite % increase in our NIA funding in the center. Dr. Hill and Dr. Nestoriak have an NIA grant now in the center, and we have a number of other folks. This is not everyone, but just to kind of show you some folks. Dr. Moore is interested in kind of early developmental changes. Dr. Collins, who is, this is one of the rare presentations that Dr. Collins is not a part of. She presents quite a bit on campus and people get to see her quite a bit. She's interested in changes in and around pregnancy. And of course, Dr. Hill's aging grant deals with blood flow in the aging heart. And of course, the impact on sleep. There's a growing interest there in our ability or our motivation to look at sleep. It is one of the risk factors for the development of cardiovascular disease. And then, of course, exercise. I'm not going to talk about this too much because I know Dr. Hellman will mention this in his presentation. He's been working in this domain for quite a while. So what I want to talk about lastly, before I turn it over to Dr. Hellman here, is where we're kind of going in the center. We're going more toward looking at exercise, aging, and HFpEF. So it's this kind of new, kind of not your father's heart failure. Looking at all of these disease processes or decrements in health through multi-organ communication. So we're not going to continue on and certainly do not aspire to or anticipate surviving looking only at the heart, but we're looking at organ-organ communication. Here, again, just a number of examples showing you how we have people positioned throughout the center that are looking at various organs and their potential interactions with the heart or the cardiovascular system writ large. So with that said, I want to now turn to a couple of our spotlight presenters today. The first speaker, I'll give a very brief introduction, is Dr. Jason Hellman. I'll go ahead and stop sharing so he can go ahead and load up his slides as I give the introduction. I think the sharing is stopped now, so you can go ahead, Jason. So Dr. Hellman has been one of the bedrocks for our center here. He was key in implementing a number of modalities. One that I skipped over years ago, he purchased a flow cytometer, which was key for our institute and our center and its growth. And he also sort of single-handedly with his group implemented a number of aspects, whether it's kind of large-scale exercise training that we're doing now. We had been doing it before in kind of pockets, and then also with these kind of larger scale metabolic phenotyping system, the Sable-Promethean system. So Dr. Hellman has a very unique training aspect, and this is one of the reasons why I wanted to get him here in front of you today, because Yes, he's interested in the cardiovascular system. Yes, he's interested in exercise, but a lot of the specific science that he's working on is quite portable and applicable to basically most chronic conditions that many other folks are interested in investigating. And so, as an associate professor here in our center and a director of the Metabolic Profiling Core, I want to turn it over to Dr. Hellman.
Thanks, Steve. Appreciate that very kind introduction. Yeah, just wanted to take the opportunity here to introduce kind of the recent work in our lab and also talk about some of the areas that Steve's touched upon in the core related to our metabolic profiling capabilities. So the talk here is kind of outlined here. I'll just give a brief resolution biology primer. That's really the main interest of my lab, and talk about the role of lipid mediators and their actions on macrophages, as macrophages are important in the effector functions in stimulating the resolution of inflammation. I'll transition into another study here where we looked at the role of exercise in stimulating macrophage phagocytosis and enhancing resolution kinetics, and then dive a little bit deeper on mechanism and look at how exercise stimulated production of these pro-resolving mediators actually promote mitochondrial respiration in macrophages. And then talk about an ongoing human study that we have with colleagues at NYU to try to test the translational potential. And as I mentioned, I tried to integrate some of the capabilities that we have in the metabolic profiling core throughout the talk here. So you're probably asking yourself, why are you interested in inflammation? We have a whole cadre of drugs that are useful at targeting these inflammatory pathways. But I would submit that there is a number of complications and drawbacks to using these. They're not to say that they're not effective, because they're clearly very effective in terminating inflammation, but prolonged use obviously has its downfalls. And one of the common side effects is impaired wound healing, increased risk of infections. And so we think there's still an opportunity here to bring a new class of molecules to better treat inflammation. And so my lab, we really think about inflammation as not being bad, right? So we probably wouldn't be here if we couldn't mount an immune response and fight off microbes. And so really it's chronic inflammation that's bad. And so, we define and think about acute inflammation as an initiation of an immune response within seconds to minutes that's characterized by the formation of edema to help facilitate leukocytes to get to the area of infection, to help facilitate neutrophil recruitment to that site. And then those neutrophils literally die and undergo apoptosis during this process and must be effectively cleared and removed by infiltrating and returning monocyte macrophages. And so we're interested namely in lipid mediators because they control distinct phases of this acute inflammatory response. And so we see that neutrophils, so-called first responders, are really driven by the production of leukotriene B4 as being one of the most strongest and well-known chemoattractants for neutrophils. And so you could see here in this nice video by the Germain group in 2013 that the quickly migrating neutrophils to the site of injury are then followed by these green infiltrating macrophages to help clear away this neutrophil swarming. And so, I'd be remiss not to mention here this other class of novel lipid mediators termed specialized pro-resolving mediators, the umbrella term to encompass lipoxins, resolvins, protectins, and merisins that are really, really critical in stimulating this return back to homeostasis, and they do that in large part by stimulating macrophage phagocytosis. And so, just a quick overview here. It's very busy here, but just wanted to point out a couple of things that. These SPMs, or specialized pro-resolving mediators, are derived from omega-3 fatty acids, E-series resolvins through fish oil, eicosapentaenoic acid, EPA, and then the D-series resolvins are largely derived from DHA, docosahexaenoic acid, through the conversion of lipoxygenase enzymes that are highlighted here in orange. And so several of these receptors have been identified to exert these pro-resolving effects on. You can see here under the cell type column that they've been identified on multiple different cell types, and they even have some non-immune actions as well, and they act on keratinocytes, for example. But you can appreciate, hopefully, on the far right-hand side that overall, one of the main effects of these signaling pathways through these receptors is through stimulating macrophage phagocytosis and inferocytosis to help promote this resolution of inflammation. And so I just want to highlight here that, these are not simply anti-inflammatory. They do have anti-inflammatory properties. They do block and prevent excessive neutrophil infiltration. However, they're also, we think of them as being pro-resolving because they actually stimulate phagocytes to do their job and to traffic out of tissues to return back to homeostasis. And so it was the identification of these class of compounds that really challenged this previous idea that inflammation just dissipates with time. Disappearance of local chemotactic stimuli and pro-inflammatory mediators, and really ushered in a new idea that resolution is an active process that gets initiated at the onset of inflammation. And so, again, this is intentionally busy here, but since the discovery and identification of these molecules, there's been a number of publications, both in humans and in rodent models, that really demonstrate that a failure to produce these compounds is associated with pathophysiology. And also downregulation of their receptors has also been implemented in these pathologies. And so we really asked a simple question: can we prolong health span and prevent inflammatory disease development by promoting pro-resolving pathways? This is where we became interested in understanding exercise and understanding really, how does exercise create this anti-inflammatory environment? It's well documented that modern intensity exercise, when performed repeatedly, leads to anti-inflammatory effects, but really the mechanisms aren't really largely known. Some are presented here and include, the activation of the sympathetic adrenal medullary axis to drive adrenaline and cortisol, which has actions on monocytes. But really, the information regarding mechanism is quite limited. And so we wanted to know, is exercise, is it only anti-inflammatory, or maybe there's a more complete way of thinking about exercise? Maybe perhaps it also promotes pro-resolving pathways. So to do this, we employed a kind of a easy acute inflammatory model in the lab. It's a zymosan-induced peritonitis. This is a self-limited model. It's short in duration, which is very convenient. The animals at this low dose of zymosan resolve within a week. And this allows us to collect different tissues and supernatants to do our analyses to really understand how resolution pathways are being impacted. And so we can use flow cytometry to enumerate different immune cell subsets. We could take that supernatant, again, as I was mentioning, and profile using our mass spectrometry and to profile the abundance of different lipid mediators throughout these distinct phases. And then really the real usefulness of this model is that it's a well-established model where the kinetics have been well identified, and so we can really quantify how resolution is being altered during this process. And so we used this peritonitis model in sedentary and exercised animals to answer our question. So here what you see is we in the core we have six lane forced treadmills where we can subject mice to treadmill running. For this particular study, we used 4 weeks of exercise training, Monday to Friday, and we exercised them at 75% of their max capacity that we determined before the onset of this. And then we allowed the animals a 1-day break and then subjected them to this acute inflammatory peritonitis model. And so hopefully you can appreciate the robust infiltration of neutrophils into the cavity at 12 hours, which was surprisingly elevated in our exercise animals. However, what was interesting for us to note was that the blue line here, the removal or the removal of these neutrophils in exercised animals compared to their sedentary controls seemed to be significantly enhanced, which resulted in an enhancement in resolution of about 7 hours, or a 30% increase in their resolution. This was associated with no change in the abundance of macrophages, which was quite surprising given their role in removing these neutrophils. But we did see an upregulation of the biosynthetic enzyme ALOX15 and the production of the pro-resolving lipid resolvin D1. So this begged the question if perhaps exercise is stimulating macrophage phagocytosis of these dying neutrophils. And so we tested that directly by isolating peritoneal macrophages, plated them on dish, and allowed them to phagocytose FTSE-labeled zymosan. And hopefully you can appreciate the significant increase in the uptake of zymosan in these macrophages, and also the elevated production of resolvin D1 during this process. And so we again went on to utilize flow cytometry in our core facility and was able to determine, I'm just for brevity's sake here, kind of skipping ahead, we were able to find that really it was this process of exercise enhancing resolution seemed to be mediated through alpha-1 adrenergic receptor. That is, when we pre-treat animals with prazosin to inhibit alpha-1, we can inhibit the exercise-induced removal of these dineutrophils. We can also inhibit the exercise-stimulated macrophage phagocytosis, as well as the production of resolvin D1 following exercise. And so kind of collectively what we've come to conclude here is that exercise, by stimulating catecholamine release, then acts on alpha-1 and macrophages to promote macrophage phagocytosis and clearance of these dineutrophils. And so all of that was in our force treadmill model. And so we begged the question if this was just an artifact of that model, or is this kind of maybe applicable to different exercise modalities. So in the next series of experiments, we utilized our voluntary wheel running system that we have in the center. I think we're up to around 50 cages that have individually housed animals, where we have running wheels that's connected to a laptop and is continuously monitoring the animal's activity. And so here I'll also take the opportunity to shamelessly plug our, as Steve was mentioning, our Sable metabolic and behavioral phenotyping system, which you could see in the exercise animals at the bottom here. The light gray is actual wheel revolutions, and how that correlates with elevations in VO2 and CO2, that is the amount of oxygen that the animals are consuming while running versus the amount of CO2 that they're actually exhaling. And you can also see we have overlaid here in dark crimson or red at the bottom, the actual movement and ped speed are just roaming around the cages. And so this probably touches upon maybe 15–20% of the different variables that the system's actually able to measure. But really, it's a complete metabolic and behavioral phenotyping system. And so following this 4 weeks of voluntary wheel running, we subjected animals to thioglycolate to elicit macrophage recruitment to the peritoneal cavity and performed lipidomics, again, using our core mass spectrometry targeted lipidomics system. And what we found was that a number of these lipid mediators that are important in this acute inflammatory response were altered in exercise animals. Namely, the production of resolvin E1, the EPA-derived SPM, was elevated following exercise, as well as, interestingly, the degradation of pro-inflammatory lipids following exercise. And what we actually also analyzed during this time, using Brad Hill's expertise in extracellular flux analysis, that macrophages isolated from exercise mice demonstrated elevated mitochondrial respiration via the readout of basal oxygen consumption rate. And so this suggested to us that perhaps SPMs may be important in stimulating mitochondrial respiration in macrophages, and this might be responsible for their increased phagocytic capacity. And so I'll just kind of skip ahead of over about 2 years worth of work, but what we found is that if we treat either mouse elicited peritoneal macs, mouse bone marrow derived macrophages, or human peripheral blood derived macrophages with different resolvins directly in a dish, we can actually stimulate mitochondrial respiration in these different macrophage subtypes. And so we dig down a little bit deeper into the actual signaling pathways. We found that AMPK, the master nutrient sensor that's been identified in numerous cell types, seemed to be responsible, at least for the induction of mitochondrial respiration following RVD1, E1, and merism-1 treatment. As you can see, that the pre-treatment with compound C to inhibit AMPK phosphorylation inhibited this SPM-induced effect. Interestingly, resolvin D1, which binds a different receptor than the other three SPMs, did not seem to be sensitive to AMPK inhibition. So that signaling pathway seems to be independent. And so transitioning to really understand if maybe there's some translational potential that exercise is promoting resolution, We turned to a cross-sectional data set using the NHANES 2003-2004 data, whereby there's been measurements performed on serum levels of fatty acids, as well as there's an assessment of cardiovascular fitness, like VO2 max, as well as measures of C-reactive protein to understand systemic levels of inflammation. And so one of the first analyses that we did in collaboration with Dan Riggs and the Environment Institute is to look at the relationship between VO2 max and circulating levels of CRP. And importantly, what we saw was this inverse relationship, which was not surprising because this has been shown in numerous other publications, but it was nice to see that also this trend held true even in this NHANES data set as well. And so when we looked at the modifying effects of different fatty acid classes on this relationship, what emerged was that medium and high levels of omega-3 fatty acids modified this relationship. That is to say that individuals with high levels of omega-3 fatty acids had a steeper slope or a more negative relationship between VO2 max and systemic inflammation. And when Dan drilled down a little bit further, looking at the levels of individual omega-3s, he found that alpha-linolenic acid and docosahexaenoic acid, a precursor for the SPMs, the D-series SPMs, seem to be responsible for modifying this inverse relationship between cardiorespiratory fitness and inflammation. And so while not a smoking gun, it's at least suggestive that perhaps omega-3s and maybe even SPMs are important in driving down inflammation with increasing levels of exercise. But to test that more directly, we're ongoing Perspire trial with our colleagues at NYU. Perspire stands for pro-resolving and pro-inflammatory responses to acute exhaustive exercise in healthy individuals. And we're currently enrolling, and basically the study design for this is to bring these individuals in, collect blood, expose them to a cardiopulmonary exercise endurance test, collect blood immediately, then 4 hours later, and then enroll them in a rigorous 3-month exercise program, bring them back and make the same measurements. And then at the end, we're going to do a deep immunophenotyping as well as, look at the levels of pro-resolving lipids and as well as their inflammatory lipids to get a sense of how these individuals responded before and after this exercise program. And so with that, I just would like to acknowledge people in the lab that did the majority of this work, and obviously our funding agencies. And then at the top, if you have any questions about the core services within the metabolic profiling core, here's my email at the top, and I'll turn it back over to Steve, and I'll stop sharing.
Great. Thanks, Dr. Hellman. So hopefully you saw his email address there. We're easy to find on the website if you need to get in contact. We'll probably hold questions for the end just to make sure that we can get through everything that Dr. Gibb has to present. So our next presenter is Dr. Andrew Gibb, one of the most recent recruits to the center. He started 18 months ago. He was an instructor at Temple University, where he secured an American Heart Association Career Development Award, which he transferred over here to the University of Louisville. Has been a participant in the 2 COBRA submissions. You don't really hear this stuff publicized because it's not really public information, but he basically got a perfect score on his part of the COBRA. So kudos to Andrew. He was a repeat offender in the second iteration of that COBRA award. So fingers crossed. I think that gets reviewed here in several weeks. And he has a pending R01 that gets reviewed in a few days. And so if he seems a bit anxious and distracted, it might be because he might be refreshing his Commons account to see if just by chance he got the score early. But Dr. Gibb has a lot of expertise in metabolism and in ventricular remodeling. He earned his PhD here under Dr. Hill. Like many of us, we either came to Louisville by choice or we were trained here. So Dr. Gibb earned his PhD here in physiology under Dr. Hill. I did a postdoctoral fellowship at Temple with John Elrod, who's a big cardiovascular investigator, runs a center there, and we were able to steal him back from Philadelphia here to Louisville because why not? Why wouldn't you want to be here? So Dr. Gibb is going to tell us a bit about his metabolic explorations in striated muscle and particularly in the heart. Andrew?
All right, thank you, Steve. And of course, thank you, Dr. Klein and the Office of Research and Innovation for giving the center and Jason and myself the spotlight here today. So as mentioned, I focus a lot on cardiovascular metabolism and how we can try to manipulate that in order to improve outcomes. And let's see here. Here we go. Okay, so I'm going to take a little bit of a different approach. As Dr. Jones just mentioned, my lab here only just recently opened in January of 2024. So I'm going to kind of take the approach of more showing you what I'm doing, what projects I'm ongoing, in hopes that we can potentially find some collaborations and ways to engage with myself here. So, but really I'm focused on understanding, as I mentioned, trying to find causes and consequences of cardiac health and disease. We use very mechanistic approaches to find novel molecular and metabolic pathways. We use a wide range of techniques from discovery-based screens, multi-omics approaches, in vitro mechanistic studies, in vivo models of both exercise for healthy heart interrogation as well as heart failure to look at cardiovascular disease. And we generate a lot of novel mutant animal models, ultimately with the goal to discover new therapies for treatment and prevention of heart disease. So one of the first active areas of research is really focused on finding ways to improve cardiac energetics via targeting cellular and mitochondrial metabolic pathways. So in particular, one of the projects that I'd like to expand a little bit more on here today is looking at the role of the metabolic enzyme glutamine synthetase in the context of heart failure. And as Dr. Jones mentioned, this is a R01 resubmission that was pretty well received and is not being reviewed in a couple of days. It is being reviewed today. So wish me luck. So the lab or myself has had a long held interest in studying glutamine metabolism in the heart. It's the most abundant amino acid in the body, yet really nothing's known about its role in cardiac health and disease. Previously, I had demonstrated that the loss of glutamine catabolism via genetic deletion of glutaminase in cardiac fibroblasts specifically reversed the profibrotic phenotype of these cells and reversed disease pathology. So while these studies began to elucidate a complex role for glutamine, even less is really known regarding its role in cardiomyocytes. So glutamine metabolism is controlled by two enzymes here. The first being glutaminase, which breaks down glutamine to glutamate by removing this ammonia group, where glutamine synthetase, which adds ammonia at the cost of 1 ATP. So while these metabolites and these reactions are involved in numerous cellular processes, we believe there's a critical role in regulating cardiac energy metabolism. Recently, it was discovered, sorry, my pointer here. There we go. Recently, it was discovered that the failing human heart actually increases glutamine production, which was indicated by differences in arterial coronary sinus metabolomic sampling. However, we didn't really know whether this could be an adaptive or maladaptive response. And so importantly, these findings in humans were also supported by recent mouse studies that demonstrated the failing heart increases glutamine production as well as the expression of glutamine synthetase in mouse failing hearts. So to begin to test out this potential role of glutamine synthetase in heart failure, we created a tamoxifen-inducible cardiomyocyte-specific knockout mouse and assessed how loss of GS impacted cardiac metabolism and energetics. So one method which we routinely use to assess cellular metabolism and energetics is via the Seahorse extracellular flux analyzer. And this allows us to monitor glycolytic and oxidative metabolism in live cells in real time. So as you can see in these graphs, in our knockout mice, loss of glutamine synthetase in isolated adult cardiomyocytes increased basal and maximal oxidative respiration, as well as glycolytic metabolism. And so with both of these in hand, this really led to a energetic profile that was enhanced in our knockout mice. We followed up these observations with another routinely used method in the lab, mass spectrometry, where we can see increases in several energetic intermediates in the knockout mice, such as an increase in ATP, the ATP to ADP ratio, free creatine, and in NAD. So as we observed that the energy state in these mice appeared to be elevated, we next asked whether deletion of GS would be beneficial in mice subjected to heart failure, where energy supply can be limited. In these studies, heart failure was induced by banding of the aorta to increase the pressure the heart pumps against. And ultimately, this increases workload and eventually leads to heart failure. So using echocardiography, which Steve indicated, we use this to assess cardiac function and is commonly used in our lab. We observed a significant increase in fractional shortening or the ability of the heart to pump blood as compared to the control mice in our knockouts. We also performed an interventional study where we determined whether after the establishment of heart failure and cardiac dysfunction, if loss of glutamine synthetase expression would prove beneficial. So here we subjected mice to our TAC pressure overload heart failure surgery, allowed them to fail for 8 weeks before providing our tamoxifen to genetically delete glutamine synthetase. And as you can see here, we see a pretty significant attenuation and mitigation of further functional decline once we delete this enzyme. And so with these preliminary results in hand, and for the grant that is being reviewed today, we've developed this working hypothesis that the activity of glutamine synthetase actually negatively affects the heart by acting as a carbon siphon, which creates kind of a leak in the energetic system, and that by limiting its activity, we can improve cardiac energetics and ameliorate heart failure. In addition to heart failure, exercise has been shown, at least within skeletal muscle, to decrease GS activity, which again could be energetically favorable. And so we're also exploring this in the context of the heart as well. Now, as Dr. Jones also mentioned, a very hot area of research right now is in organ-to-organ crosstalk. So another active area and a less explored area is not only organ-to-organ crosstalk, but this crosstalk idea within a single cell and how disruptions in organellar crosstalk between how different organelles interact or how the cytosol and the mitochondria coordinate metabolic reactions and how that could impact cellular responses to stress is really unexplored. So we have several ongoing projects interrogating this concept of organellar crosstalk and alterations in metabolite transport as a key mediator of cellular health and adaptation. So one way in which we can begin to test this idea is to investigate metabolic shuttles, which mediate organellar crosstalk. So the malate aspartate shuttle, which is critical for transporting reducing equivalents generated from the cytosolic glycolysis for oxidation within the mitochondria, and for exporting metabolites out of the mitochondria into the cytosol, is one means which we can interrogate this concept. So one specific protein of interest is the antiporter SLC25A11, which is upregulated in exercise and downregulated in the failing heart. And we really believe that that SLC25A11 within the shuttle system serves as a critical node by which cytosolic and mitochondrial communication is upheld, and that disruptions or specifically loss of this communication are a principal driver of disease. So we've been actively generating and validating genetic tools to investigate this hypothesis. We've created novel cardiomyocyte-specific tamoxifen-inducible knockout and overexpressing mouse lines for this SLC25A11 gene, which can be shown here and confirmed by these Western blots. And really supportive of our hypothesis that disruptions to the shuttle system and specifically downregulation of SLC25A11, that there's some involvement in heart failure pathology, is that you can see here in our knockout mice, they display significant cardiac dysfunction, pathological remodeling, and this ultimately leads to heart failure and eventual death as indicated by these survival curves. So we're really excited about these results as well as other preliminary results, which are very supportive of this hypothesis. And we're looking to hopefully submit an NIH R01 on this in October. And so a third focus area that I just want to focus on real quick is unraveling the mechanisms driving fibroblast differentiation and persistence, which mediate tissue fibrosis and organ dysfunction. So one such project in this area also utilizes our newly developed SLC25A11 mouse, but I also wanted to highlight some additional screening and more discovery-based approaches that we've taken in this area. So we've differentiated cardiac fibroblasts into profibrotic myofibroblasts, which are responsible for this fibrotic response. And we've correlated changes in both chromatin accessibility with differentially expressed genes via ATAC-seq and RNA-seq respectively. We then performed motif analyses on these accessible regions to identify novel transcription factors, which really we believe are mediating the fibroblast differentiation process. So in total, up to now, we've identified 6 to 8 of these novel transcription factors, which really there's nothing known about them in the context of fibroblast biology or tissue fibrosis. And we're currently working up CRISPR-edited cell lines, knockout cell lines for in vitro screening of the impact on fibroblast biology and differentiation program, ultimately with the goal, hopefully, of working these up into our preclinical models of heart failure. Most of these techniques that I've shown here kind of have been discussed throughout, with the exception of the stable isotope metabolomics. So I just wanted to kind of briefly touch on that. That's something that a lot of us in the center use.
Yeah, just about a minute or so, Andrew.
Okay. And we're able to track the fate of these carbons through different metabolic pathways. So we've routinely used this and published this in both in vitro studies, as well as are currently developing these for in vivo approaches as well. So I believe I've pretty much covered everything, but ultimately we're really trying to cover approaches and techniques that advance science through preclinical discovery, leveraging in vitro and ex vivo and in vivo methods that integrate systems biology and animal models of health and disease in order to advance our cardiovascular field. So with that, I'll skip a slide. Acknowledge some of the grant funding that I've had. My current lab, Nancy is a pharm tox second year student going into her second year that's joined my lab, so really excited. And Snig has been with me for the last year in a staff position. And with that, thank you again all, and I appreciate the opportunity to present here today. Thank you.
Thanks, Andrew. Perfect timing. So I think that, as the kids say, the TLDR is there's a lot that's going on here in the center. We have a lot of folks that would love to collaborate on a scientific basis, or if it's in terms of access to instrumentation, we're happy to chat with you. So get in touch with us and we can talk and go forward from there. But I want to make sure we have a little bit of time for Lee. I think Lee, yeah, there she is. Hi, Lee.
Hi, Stephen. Excuse me. Thank you to all three of the speakers. Wonderful today. I just personally, on a personal, I have such a family history of cardiac disease. So I appreciate anyone who's working to make discoveries that would help keep people healthier as it relates to cardiac issues. Anyone real quickly before I just briefly go over the two announcements, have any quick questions for any of the three? Okay, if not, as all three of them have mentioned, they have certainly provided their contacts and that contact information, and you should feel free to reach out to them after this session. I included in the chat, as well as it was on our agenda that went out, NIH has sent out a notice that for anyone whose award was terminated early, that is in the, or was in the established, ESI, early stage investigator. I'm getting things confused today. And it had not, their termination for their award was not anything related to misconduct or to some other disqualifying event. You can request to reinstate the ESI eligibility within ERA Commons. And then just a quick reminder that we do have access now in collaboration with the Meg Bouvier Grant Group, some free NIH training. And so I've provided the registration there, and that is open to any faculty member, postdocs, and graduate students. And all of the courses there, as well as their boot camps and First Fridays and newsletters, is free to anyone at UofL. So, and I think that concludes us for today. I hope everyone has a wonderful afternoon and stays cool. Thanks.
Thank you.
Thanks, everyone.